With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, our question is given as shown in figure, AB is rod of length 30 cm and area of cross section 1 cm square and the thermal conductivity is 336 SI units. The ends A and B are maintained at temperature 20 degrees Celsius and 40 degrees Celsius respectively. A point C of the rod is connected to a box D containing ice at 0 degrees Celsius through a highly conducting wire of negligible heat capacity. The rate at which ice melt in the box is. Here, latent heat of fusion, that is for ice, is given as 80 calorie per gram. And 4 options are given, that is 84 milligram per second, 84 gram per second, 20 milligram per second, and 40 milligram per second. So our question is to find the amount of ice which melt, the rate of amount of ice which melt. So first we can analyze the figure given here. We can consider this as two parts. That is, at C the temperature is 0 degrees Celsius, and from A to C we can see A is at a higher temperature 20 degrees Celsius and C is at a lower temperature 0 degrees Celsius. So heat flows from A to C. Heat flows from A to C and this heat is H1. Okay, we can see the point B is also at 40 degrees Celsius and C is at 0 degrees Celsius. So heat flows from B to A because B is at a higher temperature compared to C and this heat flow is given as H2. And these two heat H1 and H2 will come through this point which here is also ice melt and here the outcoming heat is H. So from this figure we get first relation that H is equal to H1 plus H2. Okay, H is equal to H1 plus H2. We can take analog for this thermal conductivity and the resistance. We can draw a analog resistance for this circuit. For this figure, this is a first resistance here A, here C, and another resistance here B, and here also D. Since D and C are at the same temperature, see here 0 degrees Celsius, 0 degrees Celsius, A is at 20 degrees Celsius, B is at 40 degrees Celsius. So length of the AC is 10 cm, length of BC is 20 cm, both area of cross section is 1 cm square. So we can write the resistance of the first one and resistance of the second one, then we can calculate the heat. So the resistance R1 is equal to L1 divided by K1 into A1. What is L1? Length of AC, that is 10 cm, 10 into 10 raised to minus 2 divided by K is temperature coefficient which is given as 336 into area is 1 cm square, that is 10 raised to minus 4. We can cancel this. So we get 1000 divided by 336. What about the resistance of a second one, that is L2 divided by K2A2. Okay, what is the length of the second rod? It is 20 cm, that is 20 into 10 raised to minus 2 divided by 336 into area is 1 cm square, so 10 raised to minus 4. On cancelling we get 2000 divided by 336, here 10 raised to minus 2. So when this 10 raised to minus 2 comes to numerator, because it becomes 20 into 100, that is 2000 divided by 336. Okay, then we can find the heat. Heat energy is equal to what is heat energy? Temperature divided by resistance. So 20 degrees Celsius divided by resistance is 1000 divided by 336. Plus for the second case is 40 degree divided by 2000 divided 336. Okay, we can calculate this, that is 336 into 20 divided by 1000 plus 336 into 40 divided by, this is 4 into 2000. Okay, we can cancel, that is 2 by 100 is 50. 4 by 200 is 50. So 336 by 50 plus 336 by 50, we get 672 divided by 50, which is given as 13.44 joule per second. So this is a heat loss. Okay. Next here, this heat is used to utilize to melt the ice. So this heat energy is used to melt this ice. So according to the latent heat of fusion, we get heat energy is equal to mass of the ice into latent heat of fusion. So mass of the ice is obtained as H divided by L. What is the L value given here? It is 80 calorie per gram. We need to convert calorie into joule. That is 80 into 4.2 joule per gram. So substituting, what is heat? 13.44 divided by 80 into 4.2. We get the answer as 40 into 10 raised to minus 3 gram per second, or we can write 40 milligram per second. So the rate of the ice melt is per second 40 milligram of ice will melt, and our answer is matches with option D, 40 milligram per second. Okay.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.